Then as I told you before, I'm gonna cover all the teams involved in this specific domain of highway construction. So number one are the environmental specialists. They come in first and foremost because many of the highways that you see when they are being constructed, because they are connecting one city to the other, if you're doing intercity, so many it may be possible that you need to cut many trees or harm the environment. So the environmental specialists come in, they see the pros and cons, and they give the government, they give the approving authority the measures on which they can save the environment, as well as simultaneously continue with the construction. So as engineers, our role is not only limited to just do construction, but also to preserve the environment. Then only I believe we can be called true engineers. Secondly, the teams that come in are the health and safety. So health and safety of each team, each person involved on the site. Even I would like to mention here, if you're a designer, you should never hesitate to go on site. Being a civil engineer, you should be ready to go on site. So even designers need to go onto the site. They should monitor what activities are going on and is everything going as per their design. Because tomorrow, if any failure occurs, it's not just one person who's executing on the site will be held responsible for. Everything will come down to the last stick. So everyone will be responsible, even the environmental specialists will be responsible for that. So to cater to all of this, we should all responsibly look after what our product is. If you've designed something, a designer should always go onto the site and see how his design, how his vision is being executed on site. So secondly, come the health and safety. So they will devise all the health and safety protocols. They will design safety manuals. They will describe what all prerequisites there should be involved when a person goes onto the site. He should be wearing a hard hat, um, uh, or highly reflective jacket, safety boots, gloves, safety glasses on the site. Then we've got surveyors. Surveyors play a very important role here. So by surveyors, I mean the people who use equipment like toll station, people who use equipment, and what levels need to be maintained, what levels need to be maintained in the design of these pavements. As I told you early on, the grade is very important. The level of each is very important so that the water is dispersed very conveniently from these pavements, and it's easy for the commuters to travel on those roads. So the surveyors come in, they take levels, and this is as per the guidance of the designer. The designer tells the surveyor, I need levels at specific intervals, say at 10 meters apiece, at a grid of 10 meters by 10 meters, at a grid of 50 meters by 20 meters. This is up to the designer, because in the end he is going to calculate how much earth or how much soil is going to be removed or is required to fill in that specific road so that that specific level can be maintained. Then we have the design engineers who will be guiding these surveyors. So all of this is interrelated. I will like to mention that, when a project starts, when the project planning starts, the project manager is selected and he selects a team. So when he selects the team, this whole bubble is created then and there. So once this bubble is being created, so all the people can interact with one another. Although their roles may come at different stages as the project progresses, but everyone knows who the environmental specialist will be, who the health and safety coordinator, health and safety manager will be, who will be involved in the survey team, how many teams of survey we need, who will be the design engineer. So everything is pre-decided in the project planning stage itself. Many a time we see that the major cause of failure, I would say, of pavements in the past has been design engineers not going to the site, not doing preliminary investigation. Many times when the site team comes, mismatch with the design. and that causes delays in the projects. That causes changes in design at various stages of the project. So these all factors contribute to the project cost getting high. And if a project cost is getting high, the project is getting delayed, it is all the taxpayers' money that is going into it. It is all the time that the commuters, that the people who are commuting that specific path are suffering. We can very well relate to this when the Delhi Metro was being constructed. The first two phases went very smooth, but the third phase there were many changes, and that caused the community to suffer a lot. So design engineers need to be on the site, and that will support the site execution and the operations team, because if a design engineer is familiar with the site conditions, they can very well relate to it when they go when the site execution and operations team go onto the site, and this will in the end function smoothly. Then we have the QAQC, that is the quality assurance and quality control teams that come into action. They will be simultaneously on the site with the site execution team. They will have specific labs set up for the projects. And for QAQC, there is a high demand these days. How can I say that? Because I have been involved in the projects myself. I have hired many QAQC engineers, and I've seen that this specific role demands a lot, but we don't have specialists in this. We don't have people who are focused into quality control and quality assurance. So QAQC comes into action. They will always check what is in the design and what is being executed on the site, and they will do the comparison. They will do compaction tests for the subgrade. They will see what kind of subgrade it is, whether it's similar to what the designers had planned in their design. They will see what is the specification for the granular layer for the base course. They will see how well the execution for the varying course is being done, whether the grades are being maintained or not. They will also go through the drawings when the surveyors prepare them, and then they will see, because when the surveyors come into action, what they normally do is they install pillars on the site. Those pillars are indicative of what area will be covered with the road and what will be the level of the road. So they mark that on the pillars by paints. So by a simple paint, they mark on the pillars what will be the levels. So the QAQC engineer, when he goes in, it's his responsibility to check everything. And mind you, a lot of documentation goes for each of the rules. So they have to abide by all the documentation, because once you have the documentation in, it is very clear that you are doing all the checks. So you need to be very firm with the documentation, and anything that comes in your domain, you should have it in writing if any changes are being involved on the site. Then we have the project management team. As I told you before, the project management team will involve the names of all these persons, all the teams that are coming in for the design, for the execution of this certain project. So the project management team would include a project manager who will be at the top. Then you will then it depends on the project whether you're dividing it into specific domains, or it's like we can have a QAQC manager as well, we can have a site manager, we can have a design manager, and then they will have their subordinates and design coordinators, site coordinator, QAQC coordinator, or you can have one project manager who will look after each and every domain. So that is how the project management team will come into action. Then finally, once the whole design, whole execution has been done, you need to do the markings on the highways. The markings are done normally with thermoplastic paints. There is a specific IS code, the Bureau of Indian Standards code, for how the markings need to be done, what colors need to be followed on the sides or on the highways. Normally, when we commute, we see specifically the dashed line, that is the separator line, is white. Normally, all the lines are white. And when you see towards the left of the highway, that divides the shoulder and the main carriageway, that is in yellow. There's also one color orange that needs to be followed when you're doing rehabilitation and you're closing a certain part of the highway. So orange color is for that. So that is all given in the IS codes. How what should be the spacing of the highway markings, that is also given on that. And in highway marking, there's one more thing, that's the installation of signboards. So that include the speed signs, that include when we give the signals, all the signboards, including a stop sign ahead or a traffic signal ahead. So all the signboards, how many kilometers of length, how many signboards should be provided, everything is given by the Bureau of Indian Standards. So we need to follow that. Even one interesting thing that I would like to point out here is even the traffic signals are designed for a specific road. That is, for how long, how many seconds the red light will be, how many seconds the green light will be active. So that is also designed based on the highway type and what load it is catering to, how much traffic is it catering to. The demo and the case studies that I will involve, this is one company that I was working for, Geotech Engineering Services in India. So they've been kind enough to let me use the photographs from their projects. So this is the survey team that is coming into action. They are taking, currently what they're doing is what you can see in the picture there. To the left, you can see a flexible pavement has been laid. What this guy is doing, this equipment that he's using is a total station. He has marked a benchmark on the manhole that he's standing on. So benchmarks are basically used to identify the points when you are conducting a survey. So manholes and other permanent structures are used to identify those benchmarks. Why are they used? Because tomorrow, like this guy has done the survey of the project at the very initial stage. When he did that, this whole area was just a jungle. When this now when the project has been executed, this manhole is a permanent feature and it will never be removed from this specific location. Now he can come, he can put his equipment on that particular point, and with this point, this is the reference point, that's why it's called the benchmark. So with this point, he can at different times see what is the level of the road that has been constructed. So going back to the slide where I discussed the fundamentals, we have the first as the subgrade, then we have the base course, then we have the wearing course. So on all three levels, he can check how much, what is the grade level and how much quantity have we used, quantity of material have we used in this particular project. So this will also help in not only determining the grade level, but also during the billing. When the contractor submits his bill, he gives the authorities the quantities that he's used. He gives the client a list of quantities of the material he's used. So this survey is effective in that prospect as well. Then we have, this is the subgrade being prepared. We have the rulers going in. You can see very well the main carriageway, where the subgrade is being prepared. The edges, the shoulders, we can see the soil has been excavated. The soil has been put onto the shoulders. So this is what we call cutting, and that is determined by the levels picked up by this guy in the first picture while doing his survey. So when this is being done, when the subgrade is being prepared, we should have we have the quality control teams that come in and they check the compaction of this. So there are many ways to do compaction checking of this. We can do it by nuclear gauges, or we can do it by other physical mechanical methods, that are the core cutter, sand replacement. So this subgrade has been prepared, and here we can see the person, he's doing the traffic study. So in this traffic study, he has asked this particular vehicle to stand on the weight pad that he has used. So here he's using he's understanding what the loading on the specific road will be, because they want to redevelop this road that he's doing the traffic survey on. So in this, traffic survey, we have many parts that go into. One is the count of the vehicles that are commuting on that specific pavement. Secondly, we do the axle load spectrum. We understand what loading will be there. So it's basically based on a standard axle load that has been defined by the Bureau of Indian Standards. We develop the MSA, that is the million standard axles. So that is from this traffic survey that we conduct. Then we have after the subgrade prepared, we have the granular course that comes in. This is the base course. You can see stones, you can see a mixture of stones and sand in this particular layer that has been following this. This is of the subgrade layer. Then you can see above this is the base course is prepared. Then we have this person who is doing vibration of the concrete. We have the concrete coming above the base course. So this is in case of a rigid pavement. And slabs are maintained. We have different parts of we have different types of pavements that come into the rigid pavements. We have continuously reinforced pavements in which the reinforcements run throughout. We have the post tension pavements. We have the normal. We have the PCC pavements. In when we the concrete that we use in case of rigid pavements is called PQC. That is the pavement quality concrete. So we can have double bars, we can have tie bars in that based on what the loading is, which is determined from the traffic survey. Then this is another case. This is a flexible pavement being laid. You can see the rollers. Ahead you can see there's a paver that is used to lay all the asphalt layer, and what thickness will be required for that specific asphalt or the bitumen layer. So that also can be seen from this picture. Even the quality control people, they are on the site with gauges. They are on the site with all the extraction equipment. So they take a sample from the paver and they test it for the amount of asphalt or the bitumen that is being used, and also the grading. And when you're doing a flexible pavement, there's another important aspect that goes into that's the temperature, because bitumen will bind at a specific temperature. Bitumen or asphalt is mainly the binding agent. The strength is given always by the aggregates. The aggregates, I mean the stones, and the grading, what kind of grading it has. So the temperature, the grading is checked on the site. The asphalt or the bitumen content, that is checked on the site. And also before a bitumen or asphaltic pavement layer is being laid, they put a coating of emulsions or bitumen again. That is called the prime coat, or it's called the tack coat, depending on what layer it is being applied on. So that is also one thing that that quality control engineer needs to look into. That is, the quantity of the emulsion that is being used. So this all includes the site activities. When we come to the design, we are going to follow IRC 58, in that we're going to understand how in the office, we sitting in the office, understanding all of these different aspects of the work, how can we assimilate and combine all the requirements for that specific road based on the survey, based on the traffic data, based on the soil conditions on the site, based on the materials available to us at our disposal, locally available. And that is one thing that I have always promoted, to use locally available materials, because we don't want extra costs in carriage. Then what is the concrete mix design? Like, what is the constituents of each ingredient used in the rigid pavement design? And when it comes to the flexible pavement, what is the quantity of bitumen that is required? What is the quantity of asphalt required for that specific design? And also conduct these designs in a laboratory, in controlled environment, to see how much strength we are getting with that particular design, whether that will fit into our site conditions or not. So this whole scenario should be clear in the mind of a design engineer before designing, and that will only lead to an effective design, and in the end, a successful completion of the project. So this is what we're going to cover during the course, and I believe I've made myself very clear, though this is a very vast topic and we need to cover a lot in that. So this is all that I could get in my presentation for today's seminar.